Thank you very much, Marcel, for a very short introduction. These days, my greatest fear is actually to, I apologize for my voice, so I had a little throat a couple of days ago, still recovering. My greatest fear is actually to have someone at the stage introducing me, following lines of Wikipedia or some other, online products, and discovering something I never heard of myself. And also, thank you for this musical introduction. I couldn't agree more that it fits more intellectual conference than a coffee break. And actually, Chopin was also not a bad choice. Just over a year ago, I was a guest at a very popular BBC radio program called Desert Island Disc. And it's an interview that's being conducted with an invited guest based on his or her choice of 8 musical themes. And one of my choices was Chopin, though it was more for my temperament. I picked up Opus 10, number 12, with the telling title, Revolutionary Etude. So now we are at the heart of the innovations in Switzerland. It's the temple of science. But before we move into AI, I have to say that it's just, we are, I guess, at the stage where we should talk more about philosophy, about the concept. What is AI? While, we understand what letter I stands for, intelligent. So letter A, for me, it's still a question mark. And also, most of the debates about AI, I think they're just conducted in some sort of religion fashion, like a medieval debates. So there's a small group preaching salvation through AI. So AI will solve all our problems. Much bigger crowd is crying over gates of hell being opened and Pandora box. So the moment it's open, we're all going to die and AI will dominate the world. So I think that people are just watching too many Hollywood movies. And I can tell you that AI is not a magic wand, but it's not a Terminator. AI is not a harbinger of utopia or dystopia. It's a tool. And I recommend that we try to concentrate on this earthy element. So it's technology that has been designed, invented, manufactured by humans. How it's going to help us? How we're going to cooperate with that? And I have my own experience with that. Most of this experience maybe is not, so pleasant, but it's useful. So, and that's why, I could speak with certain authority, though I always say I know the limits of my ignorance. And I'm not going to tell you I know all the answers for the questions that are being asked at this stage and are being asked every day at all these debates. But I know that most of the people who are telling you they do know all the answers, they don't. Also, we should recognize that we're at a very early stage where we just should talk about more philosophy, about the concept. We are, let's use the metaphor. We are at the beginning of MS-DOS, and people think we're at Windows 10. So going back to AI, so if I is about being intelligent, about intellect, it's naturally connected to chess. Because over a very long period of time, chess has been considered some sort of nexus of human creativity and intellect. Not surprisingly that great minds of the past, they looked at chess as some sort of the ultimate test of human intellect. So let's start with Alfred Binet. The end of the 19th century, the founding father of IQ test. He was so fascinated with chess players, especially with those who could play chess blind, not looking at a chessboard. And somehow he believed that if he could analyze the brains of chess players, he could unlock the secrets of human intelligence. Okay, look, it's very flattering for me, but I can tell you that the aptitude for playing chess is nothing else than an aptitude for playing chess. But again, it's not surprising that the founding fathers of computer science, Alan Turing, Claude Shannon, Norbert Wiener, they also looked at chess as the ultimate test for machine learning. They believed that when, by the way, not if, when machines could beat the best human players, that will be the dawn of, I'll call it AI. The day that machines could actually enter the human domain. By the way, a little piece of trivia, it's almost forgotten that Alan Turing actually wrote the first chess program. Yes, it's the late 40s, and there was only one game played in 1952. The irony is that there was no computer to run it. So the only game that was recorded here actually acted like a human CPU. So it's the... now, an interesting thing is that these great geniuses that were dreaming about this great moment when machine could prevail in the game of chess, they made one very important but fundamental mistake. And it's very important for us to understand why and how such great minds could be wrong. Because they knew chess was mathematically infinite game. Okay, it's not mathematically infinite in theory, but the number of legal moves calculated by Claude Shannon himself was 10 to the 46th power. It's enough for any computer to get busy to the end of time. So, if chess could not be solved, it means that machines had to emulate human thinking, so to play like humans, because brute force could not solve the problem. Now, of course, these great minds couldn't imagine that at one point we'll have access to terabytes of information. So they didn't know about Moore's law. So that's why Claude Shannon actually talked about two types of computers, type A and type B. Type A being some sort of a brute force with algorithms, and type B, it's like a dream machine that could follow this human logic and somehow to surpass human by doing similar things. Now, mistake number one, machines could do things better than humans, but not following the same algorithm. By the way, it's not just about humans, it's about nature. Airplanes are flying faster than any bird without flapping their wings. The concept of will doesn't exist in nature. So now we still keep repeating the same mistake, thinking, oh, this is the machines, either they should be perfect or it doesn't work. And that's by the way the core of this misunderstanding. We should not expect machines to be perfect because perfection doesn't exist in the universe. All we should expect is for machines being better. And that's what founding fathers underestimated. In order for a machine to prevail in a game of chess, in the game of Go, in the game of Dota, in StarCraft, I'll mention these games later on, machines doesn't have to be perfect. They just have to make fewer mistakes than human. And by the way, even the best of us, whether we're chess players or Go players or video games players or Texas Hold'em players, we all are poised to make mistakes because we're human. And the machines will just outperform us, you could say outthink us, by doing it even slightly better. It doesn't mean they have to understand what they're doing. Who cares? It's about the result. So naturally, with such big expectations about the game of chess, the chess programming has been flourishing. And just before we move on, so this is just a demonstration of what I said about the possible chess positions, also chess game tree complexity, also calculated by Claude Shannon. So as you can see, the tree just becomes endless. So there's no way machines could actually calculate everything. By the way, they don't have to. So this is again, the minimax algorithm and alphabet pruning. They'll come up later by simply helping machines to dramatically reduce this tree and to increase the quality of their moves and make them already competitive with the chess players. But a part of the big machines, there was a thriving business of chess computers. I mean, judging from the average of the audience, I guess there are a few chess fans. Maybe you still owe this piece of antique called chess computers. Even some of them carried my name. Anybody still has it at home? I don't. Oh, yes, I could see 2 hands. Wow. Oh, no, actually, I see 6 hands already. So, and they were very popular in the mid-'80s up to the late '80s. And in 1985, I entered the competition of facing chess computers in Hamburg, June 1985, just a few months before I played another match with Garry Kasparov, beating him and becoming the youngest world champion in history. So in this exhibition, and that's For those who don't play chess, it's simultaneous exhibition when you go around facing a bunch of amateurs or sometimes club players. I face 32 individuals, humans, who have not been playing chess but simply executing moves suggested by the computers. There were 32 of them, 4 leading manufacturers presented 8 their best models, and I had to go around playing against them. I won all the games. Now, what is interesting? It was not a big surprise. It was not a shock. Actually, I can tell you, if I couldn't win all the games, that would be the shock. Because people say, okay, it's a joke, so maybe Garry could make a mistake, but he concentrated, so he won all the games. When I look at this picture, it reminds me of the golden age of human-machine relations. Machines were weak, but my hair was strong. Just 12 years later, I faced only one computer. By the way, I always have to tell people that it was a rematch, because I won the first one in Philadelphia in 1996, just for the sake of historical correctness. Now, actually, in a previous commentary, so I heard this as, about humans facing machines as a phenomenal challenge. Look, we thought it other way around. Because we played machines. Not that this match was the first one we played. We played machines in 92, 93, chess engines. It's an early version of Fritz, and then the junior Israeli program came in. And we knew that the games, 5-minute games, blitz chess, 10 minutes, 25 minutes, so-called rapid chess, machines could actually occasionally beat chess players. The mistake we made, again, it's a typical psychological mistake that is being made, is that we thought, oh, if we add time, if we play normal tournament game under 6 hours or 7 hours time control, now we'll not make this mistake, so machines will be doomed. The machines could also get better. Again, it's about the Moore's law and about better algorithms. And again, about machines not being complacent. I could say having steady hand. So, if we look for the watershed moment in these relations, human-machine relations, actually it was not 97 match, but 96. I said I won the match, but I lost game 1. I lost game 1, I fought back, won 3 games, won the match. But the very fact that machine could beat sitting world champion in a normal tournament game, 7 hours or 6 hours time control, that was already like a writing on the wall. The rest was a matter of time. I know it now. But in 1997, I still thought, okay, it could take longer. And actually, Deep Blue was not a monster as it's been portrayed. So if you analyze games that we played in 1997 with the chess engine that is available, you can buy it and just install on your laptop, they'll show that we made many mistakes. The problem is I made more mistakes. And of course, it's psychology also. The cover story of Newsweek said, "The brain's last stand." No pressure. And I have to say that I underestimated the ability of IBM scientists actually to come up with significant improvements. As a matter of fact, it's almost forgotten that it's a team that came from Carnegie Mellon University, and they developed the program called Deep Thought. And it's this program which in 1998 beat the first grandmaster, in average grandmaster in normal tournament. In 1989, I played 2 games, rapid chess games, won quite handily. But then, of course, IBM took the team, they made it much stronger, it ended up with Deep Blue. And, I have to say I was complacent, I was not well prepared. Some people said that my biggest mistake was not ask for IBM's options, because the stock rose 22% in 2 weeks. Actually, I'm thinking about other mistakes I made. But what is very important, that everywhere, you can read today, the dawn of AI. This is the moment that Alan Turing, Claude Shannon, Norbert Wiener, all the founding fathers, they have been dreaming. And it was not AI. It was dumb. It was as intelligent as your alarm clock. a very expensive one, $10 million. But still, it's not intelligent. It didn't have to be intelligent. All it had to do is to make fewer mistakes. And it did. So we just realized that it's all the games that we're playing, they will be eventually cracked, not because machines can solve it, but because they'll reach a point where they will expose human vulnerability. Now, so it was the end of the story. People say, it's over. But the problem is, many animals run faster than humans. Not even talking about cars. But we still have track and field competitions. So it's about humans playing each other. There are many other exciting things about the game of chess. And first of all, I wanted to play a real rematch with Deep Blue. And I challenged IBM. They made a good business decision not to accept the challenge. So when I said Deep Blue was unintelligent, I probably have to take my words back. It was intelligent enough to recognize that I was strong enough to actually give them a good fight, probably still have a good chance of winning. Because when you look at the competitions between humans and machines, it took another 7 or 8 years before it became totally futile. And by the way, this cycle of chess shows the pattern everywhere. In the beginning, you look at the challenge for the machine, you say, it's impossible. Then machines, as I remember in Hamburg 85, laughingly weak. And then there's the window called opportunity when we can compete. It's a short window. And then machines are far better forever after. I still thought I had a chance. I tried to get them to play, so they walked away. As I said, good business decision, bad for science, but again, their choice, so I could hardly blame them for doing what was right for the corporation, not paying much attention to the interest of humanity. But I was still trying to find Deep Blue, so just what the hell is this machine was doing? It's this prototype of AI. So first I thought it was directing traffic in Philadelphia. Actually, eventually I found out it's making sushi in JFK Airport. In Terminal 5, JetBlue. I love sushi, I never ate there, as you can guess. It's very painful because I fly so often, and it's just every second flight goes through this terminal, domestic flight. Okay. So what's next? Yeah, I was badly wounded. I was licking my wounds. I was pensive. I was ruminating, what about my future, the future of the game of chess? And then I thought, wait a second. If we cannot fight them, join them. So how about combining human creativity, human intuition with machines' brute force of calculation and memory? So I came up with a concept just next year in 1998 that I called advanced chess. So it's human plus machine facing another human plus machine. Now, in theory, it could be a perfect game because no more blunders, so we can actually follow the machines. Oh, by the way, show this picture. It's a match I played against one of the top players of that time, Veselin Topalov from Bulgaria. When I show this picture to my 12-year-old daughter, she doesn't recognize these massive, bulky things as computers. Yeah, by the way, just tells you about progress. So if you have a free chess app on your mobile device, it's stronger than the Blue today. Just Moore's law. Now, the interesting thing is that, contrary to my expectations, the quality of the games was not as perfect as expected. And it took time for us to actually understand that's a formula. Some call it Kasparov's law. Is that when you have a combination of human and machine, it's not about the strongest, most talented human. It's not about the fastest and most advanced computer. It's about superior process. It's about interface. So in chess, actually, the best results are achieved not by having strongest chess player with the fastest machine, but a good chess expert with a good computer or several computers who knows how to extract the best out of these machines. Because it's about centaur. It's about getting the best result from both worlds. So superior process is a key element. And I guess it goes way beyond chess. So when you look at, say, just its medical diagnosis. So I believe in many cases, You rather have an experienced nurse working with a machine than a top professor for a simple reason, the same as in chess. When I say we, people who are on the top of their profession, they can hardly accept the fact that the machine knows many things better. So it hurts our pride. And we tend to challenge things that we should let go. So that's why it's very important to understand exactly what are the areas of machines deficiency where we can actually make our human contribution. And people who are not, on the top of their profession, they could actually recognize it better and to add it to this combination. But Deep Blue, and by the way, the Watson that was shown, and almost everything we use today, they're still type A machines, according to Claude Shannon. It's still very much brute force. Better algorithms, or you may call it optimization. Machines that have been working more and more effectively, showing great efficiency, working with the human-generated data. I would call it optimization. Now, what about transformation? What about this great world of AI that is being predicted? And actually, I think now we are seeing the first glimpse of that. Alphago has been already mentioned. But since there's so much confusion, I have to take more time. Unfortunately, as a chess player, I cannot look at this clock because I already lost on time. But I believe it's so important that I would continue losing on time and just want to update you on the situation since there's so much confusion with AlphaGo, AlphaGo 0, Alpha 0, and many other alphas. Okay, just stay with me because it's a bit complicated, but it will give you, I think, a pretty good idea. So where we are today. So this diagram shows you the increase in strength of machines and also an increase of rating of the chess players. Rating it's a system that has been used since the late 60s to measure the performance of the chess players. As you can see, we have Bobby Fischer. It's 1972 with phenomenal 2785. I say phenomenal because there were no other players in 2700 category. So the gap between him and the rest was 150 plus points. Then you could see my highest rating, 2851. At that time, nobody was in 2800 category. You can see Magnus Carlsen, top 2882. Now he's 2840 something. So, but again, without wasting too much time, you could see that it's a linear improvement very much based on inflation. Because more players you have on the bottom of the pyramid, so more points could actually be shifted to the top. So improvement is, when you look at the world champions, is almost, irrelevant. You could see the machines, the very thin blue line, and you could see that these from 60s, from the very, very primitive machines to Deep Blue, which at the time when we played was still, I guess, weaker, objectively analyzing the games. So looking at the quality of the moves. But again, being objectively stronger or weaker doesn't matter if you make mistakes in the game, in the match. So, and now you could see the machines, the chess engines, like Stockfish, Commodore, Houdini, at 3400. Now, just to illustrate my point from the previous slide about combination of human and machine, you could see now, you can understand that the gap between Magnus Carlsen, the current world champion, and strongest chess engine is about the same as between Usain Bolt and Ferrari. So that's why having a very strong player working with machine doesn't help, because you should not challenge most of the machine's assumptions. You should actually look for little deficiencies where you can actually add your human creativity, your human input. So that's the gradual improvement. So you could look at this diagram. So what's changed is the appearance of Alpha program. I call it Alpha because it has been developed under the guidance of Demis Hassabis. He's a very good friend. So he used to be a very decent chess player when he was young. And they started working at this DeepMind project under Google's umbrella with Go. Because Go is far more complex than chess. There's so many options from move one. And that's why the simple algorithms that's relatively simple algorithms that have been used for chess engines didn't work out. You could remember probably the pictures. That's the deep Alphago beat strongest Go players, number 1 and number 2. So it was a decisive victory. Now, what was interesting is that very often I heard, and I'm not an expert in Go, as I said, I know limits of my ignorance, but I could actually hear them saying, oh, they made a move, machine made a move we never thought about. I said, big deal. Go is so complicated, that's why your level of understanding of the Go is like chess players 200 years ago. So that's why some of the moves that are so new, so revolutionary, but it's not that should be working in chess. And then Dennis Hassabis and his team, they had a great idea. They thought, wait a second, how about creating a program that they call Alphago 0? This is the same program, the same algorithm, but with 0 human input, only rules, just rules. This machine played millions and millions of games against itself, generated its own data, and then Alphago 0 faced Alphago, the same algorithm that has been taught every game that humans played, every bit of human wisdom. Probably some people know the score, but can you guess what's happened in 100 games match? 100-0. 100 wins, 0 losses. Alphago 0 trashed Alphago. That was quite a shocking experience because we just realized that the human data, the information that we have been collecting over decades, if not centuries, could be a liability. And then, of course, I entered the field and I said, Demis, come on, it's Go. Try chess. We have much better knowledge of the game, much better understanding. Our data is very sophisticated. This is not like challenging chess players from the beginning of the 19th century. Let's try Alpha Chess 0. They did. That's what you could see here. In 4.5 hours, this algorithm played 60 million games against itself. 60 million. Actually, I saw first few games, it was total nonsense. Just knew only the rules. Of course, you need access to Google's machine power to play 60 million games in 4.5 hours. Don't try to repeat this experiment at home. Machine generated its own data, its own algorithm of how to play chess. And then they put it against Stockfish, one of the strongest chess engines. We have to accept the fact that Stockfish was not adequately prepared. They could be stronger, faster hardware. They could have a better opening book. But the most important thing is that's actually, when you look at the games, is that the way AlphaZero played. They played 100 games match, 28 wins, 72 draws, not a single loss, which was quite phenomenal. But interesting thing is the way AlphaZero played. It played very aggressive chess, totally, refuting our expectations that stronger machines are, duller the game is. Because strong machines, they will see immediate refutation of all the combinations, so the game will last forever, it will be very slow maneuvering. It played differently. Now, Martin, you made a couple of, again, psychological mistakes talking about aggressive style, about sacrifices. Machine doesn't play aggressively, doesn't sacrifice. It doesn't understand what it is. It looks at the odds. What's happened with AlphaZero is actually through the 60 million games database it created for itself. It could see very intricate connections between material, time, and quality, recognizing that by sacrificing, in human terms, something, it could add more in value, which is very difficult for machines to compare because it's not like apples and oranges and, potatoes. But actually, it could see this connection. And that's why in this match, I think the most amazing thing for me was just to look at the logs. AlphaZero was about 2-3 plies, 1 and 1.5 moves, ahead of Stockfish, recognizing what's happening. And at the same time, Stockfish looked at 6 million positions per second, and AlphaZero for 60,000 only. So that tells you that we are actually seeing something new. And that's already the beginning of transformation. So we are looking at computers that could start generating their own data. Now, is it the end of us, humanity? I don't think so. It just offers us this new angle of observation. if we know how to use it. Because at the end of the day, and that's very important, when you look at chess, you look at Go, you look at Dota. By the way, recently, just last week, Alpha, I don't know, Zero, crushed the best StarCraft player. Just total devastation. But all these games, they are closed systems. Closed systems with a well-defined target. It's like a framework. And machines can operate in this framework much better than humans, even without direct human input. But for those who tell you that machines could automatically transfer the knowledge from a closed system into open-ended system, I don't see a shred of evidence, sorry. It's not going to happen anytime soon. And how can we use this? Just, quick look. So we know that, for instance, at Waymo, so at Google, they run I think it's 10 million miles in real roads, and the same amount, but then billions of miles virtually. People say, oh, virtual billion miles is not as good. Yes, but it's still, it offers you data. So you can do many things virtually. That's, that AlphaZero concept. And you could actually make better predictions. And again, when we talk about, say, driverless cars, people say, oh, they're not safe. By what definition they're not safe? Do they crash time and again? Yes, they do. But you compare safety in driverless car and the number of accidents caused by humans, it's incompatible. Every story about the crash of driverless car is the front page of a newspaper. The fact is that in the United States, only 40,000 people being killed in car accidents. It's like, so what? We're used to that. So we are actually facing the same problem as happened with many technologies before. People are not comfortable if technology is not perfect. But again, we should not expect it to be perfect. We should expect it to perform better. And recently, it's last May, you could look at the Tesla job announcements. It's about game designers. It's about virtual reality. So they follow in the same path. They try to actually emulate as many situations as they can virtually. Now, having said that, you can look at me and say, Mr. Kasparov, why you are an incorrigible optimist? So what's left for us humans? Maybe all these doomsayers, they have a point. Maybe we are just, we'll be extinct. Not so fast. And often, when you're getting desperate in science, look at the art. And leave it for the artist to get at the heart of the matter. Computers are useless. They only can give you answers. Now, Picasso, ancient ages ago, what did he know? But that's a very important piece of wisdom. Like, all this sounds like a paradox. As an artist who had to reinvent himself, he knew that the questions are a beginning and answers is the end. And you have to ask the right question. Can machine ask questions? Yes, they can. They just don't know what questions are relevant. And that gives us not just hope, but I think, expectations of a bright future. So we just have to look into the future, recognizing that it means that relations between humans and machines will change, but there is always room for us. And I understand I just, don't want to, we'll just look at this in a second. I don't want to sound callous. People say, oh, so many jobs will be lost. But that's a history of civilization. 200 years ago, 90+% of people have been busy in agriculture. What's happened with these jobs? 100 years ago, throughout the 20th century, most of the people have been involved in manufacturing industries. So what's happened with these jobs? The difference is today AI is threatening white-collar jobs. People with college degrees and Twitter accounts. That's why we talk about it so much. But following that's the previous speaker, and that's about the universal healthcare. When people say, oh, many jobs, well-paid jobs will be in great danger. Let's say in radiology. Yeah, you're right. So AI could actually do a very good job in just, in pushing, things further, and some of the jobs could be irrelevant. But at the same time, it will make it cheaper and more affordable. Yes, you can lose hundreds, maybe thousands of jobs in Europe and America versus maybe hundreds of thousands of millions of lives being saved in Africa and Asia. Saved lives, not jobs. So if we understand we're humanity, so we're just human race, we should look at the bigger picture. Again, I don't want just to sound callous. I don't want just to pretend that it's the pain of people who are just facing potential threat from AI is just not there. Again, I also play Deep Blue, so you can forgive me for being so pushy. But now let's go quickly over just a few points that I believe are important. Number one is machines don't have to be perfect, only better. Now, second is AI. Here, I strongly recommend not to use artificial intelligence for two reasons. One is augmented intelligence. It's a better reflection of human-machine relations for the future. Second one is actually, it's more psychological, again, because the moment we say artificial, it sounds like alien. That helps all these dark images of the Hollywood production. So people are instinctively afraid of that, though augmented sounds friendly. And machines get smarter, we get smarter. And AI will do things differently, not like humans. So we should not demand full explainability if we want to get better results. Yeah, sometimes, we will not recognize exactly why certain decisions are being made, but at the end of the day, again, we want to improve the performance, and we want us actually to be part of this process. But it's humans who always define the problems. And virtual data and machine-generated data will only increase. And important thing, AI will do more rote work. And people say, oh, what is a rote work? It's this, because the moment you say rote, repetitive work, it's about something physical. The McKinsey research of US job market in 2016 shows that when you look at the working activities that require medium human creativity, 4%. 4%, which means 96% of jobs could be not in jeopardy, but you have to reconsider them. We have been raising generations of people who just do work that is, again, rote and repetitive. So it's a challenge, but we should not cry over spilled milk. It's not about trying to slow it down. I believe it's about speeding it up, because the jobs that are doomed for progress, they are gone. You can protract the agony, but it means you will slow down the process of creating new industries with new jobs, generating new profits, new financial cushion that could help people to actually relocate and relearn. So the bottom line, we're not being replaced, we're being promoted. And to finish my presentation on an optimistic note, let's go back to Hollywood. So you think why it's positive, why it's optimistic? Okay, I'm sure many remember Empire Strikes Back, the second original movie of Star Wars. And that's a great moment. Han Solo is trying to escape from Imperial Guard, heading for the asteroid field. And C-3PO in his squeaky voice is telling him, the chances of surviving in the asteroid field is 3,720 to 1. The answer is, never tell me the odds. Why this picture is relevant? Ironically, both are right. Does machine know the odds? Absolutely. Machine does know the odds. The chances of surviving in an asteroid field are slim to none. But Han Solo also is right, because there is no other option. From machine's perspective, simply look at the odds. Being caught by Imperial Guard and being killed in 10 minutes is better than to die in 10 seconds. But there's zero chance of survival. So somehow you need humans' expertise to actually defy the odds. So that's why, again, I remain an optimist, and I believe it's a new challenge. The challenge, like many we faced before, and I'm very proud to be part of this human-machine history, and I'm very happy that I could share my experience and my expectations and my forecast with you tonight. Thank you.